universe has detected a series of devastating, high-energy bursts, erupting from an unknown source far off in space.
It began as faint data points buried in endless streams of numbers. Then came the realization. The signal was repeating like a metronome, like something alive. No natural model explained it, and every test only deepened the mystery.
One possibility is that it really was a signal from deep space coming from some other society.
Across labs and observatories, disbelief turned to awe. Had humanity just stumbled onto the first undeniable trace of intelligence beyond Earth?
We've been absolutely confident that these are extragalactic sources.
Or something stranger still? NASA just detected a pulsing heartbeat in deep space, and it's not natural.
If it's true, it would be the discovery of a lifetime.
The universe just spoke again. Every generation of astronomers has faced moments when the sky delivered something no one expected. In the 1970s, a radio telescope in Ohio picked up a burst that lasted only 72 seconds. The signal was so unusual that one researcher circled it and wrote a single word in the margins: wow.
It's this big telescope is scanning the sky, and it's just collecting, like, how strong is this radio wave coming in, and what's its frequency, right?
Decades later, fast radio bursts began lighting up our detectors. Flashes of energy more powerful than entire galaxies, yet lasting only a fraction of a second. Each time, science scrambled to explain them, and each time the explanations fell short. The cosmos is not a machine ticking on a perfect schedule. It shifts, it surprises, and at times it hurls mysteries at us with no warning, tearing at the edges of what we believe we understand. And this isn't a new story. History makes it clear that space has always tested the boundaries of our imagination, leaving behind moments that still haunt science to this day. Back in the 1970s, a massive radio telescope in Ohio recorded a strange burst that lasted just over 1 minute. It was so sharp, so clear, that the astronomer on duty circled the data and scrawled a single word in disbelief. Wow. That single moment became one of the most enduring mysteries in the search for extraterrestrial intelligence. Years later, astronomers began detecting flashes of radio energy, known as fast radio bursts. Some appeared once and never again. Others repeated with unnerving regularity. Each one carried more energy than entire galaxies released in the same instant. And yet, they vanished almost as quickly as they arrived. Scientists proposed magnetars, collapsing stars, even exotic physics, but no theory has ever fit all the evidence. These stories share one theme: the universe is not predictable. Just when we think we have its rules written down, it rewrites them in the sky. What is happening with 3I Atlas carries an unsettling sense of déjà vu. Another unexplained anomaly, another signal pulsing from the dark, another reminder that the universe may be speaking in a language we still do not understand. The signal that shouldn't exist. For decades, astronomers and engineers have refined their craft to capture the faintest cosmic traces, the afterglow of the Big Bang, elusive neutrinos.
Began with the Big Bang, almost 14 billion years ago. Nothing really happened in our neck of the universe until about 3 billion years later.
The tiny pulls of planets orbiting distant stars. Instruments like the James Webb Space Telescope are designed to filter this noise and search for structure hidden in chaos. Yet no one truly anticipated what surfaced in August 2025. The signal that Webb detected defied easy explanation. It was not the steady hum of cosmic background radiation, nor the familiar fingerprints of well-studied astronomical events. Reports suggested something different: a rhythm, a pulse, patterns repeating with a precision that seemed out of place in the natural order of space. Mission Control withheld judgment. Every possible explanation had to be exhausted. Technical error, instrument glitch, a rare astrophysical event. Yet the unease only grew, because if none of those fit, what remained? Could it, however unlikely, be artificial? A signal marked by intention? For centuries, telescopes of glass and radio dishes have expanded the horizon of human knowledge. The Webb, with its unmatched sensitivity, has revealed ancient galaxies and decoded alien atmospheres. But it was never meant to listen for structured messages. Now the team found themselves at the very edge of the known, staring into the possibility of information whose meaning was locked away. The line between observer and observed blurred. Had humanity simply picked up a strange but random event? Or had we stumbled onto something far greater?
The largest telescope ever flown launched into deep space on Christmas Day 2021. Recently, we got a look at some captivating images as Webb peers back toward the origin.
Why did NASA put James Webb in safe mode? NASA just shut down the James Webb Space Telescope after it detected something unusual. A signal, not random noise, structured, intentional. Within minutes, engineers forced Webb into safe mode. Data streams locked, communications tightened. The world was left to speculate. Was it a natural event, unlike anything ever seen before? Or was it a transmission no one is ready to decode? If the universe just knocked, do we even dare to answer? This is not the first time Webb has pushed the limits of what we know. Since its launch, the Golden Observatory, stationed nearly 1 million miles from Earth, has rewritten textbooks. Shielded by layers the size of a tennis court, it has seen deeper into the cosmos than any human instrument in history. It captured the earliest light of galaxies, revealed hidden exoplanets, and raised profound questions. Are we truly alone? What lies beyond the faint wash of ordinary stars? But in August 2025, something changed. NASA's control rooms, usually flooded with raw cosmic data, picked up something different. Streams of numbers, radiation readings, light curves. A pattern began to emerge. Clean, repeating, impossible to dismiss as noise. Inside mission control, the response was immediate. Webb was placed into shutdown mode, a move so drastic it signaled one thing: whatever came through was serious enough to halt the world's most powerful eye in the sky. The telescope that had pulled back the veil of time was suddenly silent. Its mirrors turned away from the deep. Its data is sealed under heightened security. And in that silence, one question grew louder. What exactly did James Webb hear in the darkness?
If you are just listening to this object, that the scientific story would still be communicated in a way that made sense and that was also pleasing.
Optical red flags. No existing model of solar heating or cometary outgassing could account for what scientists were seeing. The intensity of the light, its perfect timing, and its refusal to fade left researchers with an unsettling puzzle. Here was a body that was too bright, too steady, and too self-contained to belong in any known category. The usual rules of comets no longer applied. To the teams monitoring Atlas, the next logical step was clear. If the glow wasn't coming from the surface, then the answer had to lie deeper inside. Infrared analysts working on the Webb telescope began breaking down the time series data, hunting for structure in the heat radiating from its core. What they uncovered was not chaos, but rhythm. Every 4 hours, the object brightened and dimmed in a slow, deliberate cycle. The pulse was consistent, measured, almost mechanical. Energy swelled at the center, radiating outward in waves like a heartbeat. Dr. Alina Marovich and her team compared the intervals against the object's rotation and orbit. Nothing matched. The cycle had nothing to do with sunlight, surface cracks, or any of the familiar cometary processes. The heat seemed to emerge from deep within, untouched by its angle to the sun or its distance from it. To the Webb operators, the glow was no longer behaving like natural outgassing. It looked engineered. As the mystery grew, radio observatories across the world turned their attention to Atlas. The Allen Telescope Array in California, under the direction of Dr. Kavita Ralph, sifted through hours of wideband recordings. Hidden beneath the background static, they found something startling. A faint, narrow pulse repeating every 4 hours, perfectly synchronized with the thermal heartbeat. Fourier analysis confirmed it was not a random fluctuation. The signal stood out sharp and stable against the cosmic noise, precise enough to suggest intent. Other facilities from South Africa to Europe quickly confirmed the finding. The pulse was real, and its timing shifted in sync with changes in the solar wind, as though the source was reacting to its environment. Local interference was ruled out. The signal spread across the globe, detected in multiple hemispheres, leaving little room for dismissal. Scientists could no longer treat it as just another quirk of nature. Then Webb's live feed caught something even stranger. Atlas flared, its brightness climbing by nearly 40% in under an hour. Ground satellites confirmed it, and every telescope locked on recorded the same surge, not only in visible light, but in heat as well. For a brief moment, the object radiated as if something inside had awakened. When the flare subsided, its glow remained, holding steady at a stronger level than before. Attention quickly shifted from the signals to the orbit. The European Space Agency's Near-Earth Object Team, led by Marco Michelli, recalculated its trajectory. Months of tracking data suddenly no longer fit. Instead of drifting along a passive path, Atlas had shifted course, bending closer toward the plane of the solar system. The numbers hinted at acceleration, a change of motion that did not belong to natural comet behavior. For the first time, the flare, the pulse, and the altered orbit all lined up. The logs suggested something remarkable. Atlas had not only brightened, it had maneuvered, and that realization changed the nature of the mystery entirely. Blueprint of doubt. In the vacuum of official updates, rumors surged. Speculation spread about what the James Webb Space Telescope might have truly uncovered. Was it a new kind of cosmic phenomenon, so rare and powerful that it had escaped prediction for generations? Or was it something even more unsettling? An echo of intelligence, deliberate and purposeful, resonating from an unknown corner of the cosmos. Inside Mission Control, teams of scientists, mathematicians, and analysts worked relentlessly. They combed through raw data, mapped every repetition, checked for possible system glitches, and tested against known forms of cosmic interference. Any patterns that surfaced were compared to both natural and artificial templates. Some researchers noted that while nature is complex, it rarely produces perfectly ordered rhythms without reason. Others urged patience, warning that speculation must never outrun evidence. No one could yet claim to have cracked the code of the anomaly. If there was structure in the signal, its meaning remained locked away. For astronomers trained to extract order from chaos, the enforced silence of Webb spoke louder than any broadcast. The telescope that once unraveled the history of stars and traced the birth of galaxies was now bound to a new riddle, one that sat just beyond comprehension. Even the most skeptical voices admitted that if the signal proved natural, it would transform our understanding of the universe. If it proved otherwise, it could mark the dawn of a new chapter in science, and perhaps in humanity itself. Because there is a unique unease in confronting the ordered unknown. Something etched into the fabric of space with apparent precision inspires awe, but also fear. Webb's silence only made the question more urgent. Was this anomaly a fleeting moment, or the first sign of something still unfolding?
The way that I get to have that visceral sensory experience of the universe.
The pulse of interpretation. Maybe the true mystery was never the signal itself, but the way humanity struggled to interpret what might have been the first whisper from beyond the stars. The world's top institutions launched into action, poring over the anomaly with every tool they could muster. Computer scientists searched for hidden structures, while mathematicians tested for sequences, rhythms, and patterns that hinted at design. Historians and anthropologists stepped in too, warning that throughout history, first encounters have never left civilizations unchanged. Any message, if one existed, could be shaped as much by culture and perception as by the data itself. Political leaders framed the moment in terms of risk and opportunity. The unknown was no longer distant, but woven into the very fabric of global strategy. Would information be shared freely or kept under lock and key? Debate erupted across nations over secrecy, transparency, and preparation. For the first time, the question of how humanity might respond to the wider cosmos was no longer theoretical. Silence itself, some argued, could carry a message. Beyond the laboratories and government halls, the world reacted in its own way. Writers, artists, and filmmakers turned the event into myth, each interpretation balancing awe with dread. Some imagined a future of connection, others foresaw a warning. In the shadows of uncertainty, conspiracy theories flourished. Rumors claimed authorities were withholding the truth, while more extravagant tales spun stories with little foundation but wide appeal. Through it all, scientists urged patience. They reminded the public that real answers take time, and evidence, not speculation, would determine the true meaning of the anomaly. Yet one fact had already become clear. The signal had done more than stir curiosity. It had forced humanity to reconsider every assumption about its place in the universe. The long echo. Imagine a signal that began its journey long before human history even started. A whisper launched across the void of space, crossing millions of years to finally reach us now. By the time it arrived, the senders, if they ever existed, could already be gone, their civilization erased by time. Even if the anomaly was a natural phenomenon, its sudden appearance in our age was enough to rattle the very foundations of science. Light and radio waves travel at finite speeds, which means every signal we capture is a message from the past. To hear it now is to look into a window of history written not on stone or paper, but on the fabric of space itself. And with that realization comes an unsettling truth. The universe may not only be vast, it may also be haunted by echoes of lives and intelligences long vanished. The implications were staggering. Economists debated how the idea of other intelligence, even if only suspected, would reshape funding, innovation, and risk. Futurists and sociologists speculated on what it meant for humanity's trajectory. Markets adjusted, imaginations expanded, and even casual conversations at dinner tables shifted. For some, it was a beacon of hope. For others, a chilling reminder of how small, fragile, and unprepared humanity might be in the face of the unknown. Inside laboratories and lecture halls, the atmosphere grew heavy with anticipation. NASA's decision to suspend the Webb telescope was no longer seen as simple procedure, but as a historic pause. In that silence, the world recognized it was standing at a crossroads. The uncertainty itself had become the discovery, carrying as much weight as any signal the stars had ever delivered. The weight of uncertainty. What if the greatest discovery wasn't the signal itself, but the heavy silence that followed, the unbearable weight of not knowing what it truly meant? Governments moved swiftly, assembling task forces, security committees, and panels of advisors. Their mission was twofold: protect the telescope's data and shape how the world would understand an incident that lived in the narrow space between fact and mystery. For some, the signal inspired hope, a chance to uncover truths beyond imagination. For others, it carried a darker weight, the risk of knowledge humanity might not be ready to face. Meanwhile, NASA's James Webb Space Telescope faced its own battles. Like many scientific projects, it was shadowed by debates over funding and politics. Questions grew over whether the shutdown, or its timing, had more to do with resources and priorities than with science itself. Through it all, scientists held the line. They checked every instrument, they tested for interference, software errors, and even the possibility of corrupted data. Yet the anomaly persisted, slipping past each safeguard. Where ordinary explanations ended, the unknown remained. Researchers urged caution. Not every strange signal signals something extraordinary. Some mysteries vanish under closer inspection, explained away as faulty hardware, random cosmic noise, or phenomena only now entering human detection. But the psychological effect was undeniable. Both astronomers and the public were reminded that the universe is not silent, but alive with possibility. To listen for voices in the dark sky is to risk hearing something you cannot explain. That act of listening exposes humanity to not only discovery, but also the vast weight of uncertainty. Classrooms, newsrooms, and coffee shops echoed with speculation. People wondered how a new understanding, if it ever came, might reshape how we see ourselves. And in the silence left behind, one truth lingered. Even the slightest disruption to our long-held belief in cosmic solitude could shake an entire generation. A heartbeat in space. In July of 2025, astronomers came across something so unusual that it made them pause. Cutting through the vast darkness of space was an object unlike anything they had tracked before. They would go on to name it 3I Atlas, but at the moment of discovery, what mattered most was the mystery it carried.
It may well be just a rock which has some ice on the surface that evaporates.
Was this a natural wanderer drifting through the cosmos? Only the third interstellar visitor humanity has ever tracked. It enters our solar system at a velocity no natural comet should sustain. At first, it appears to be another icy wanderer from beyond. But then, the James Webb Telescope locks onto it and everything changes. Instead of faint reflected sunlight, the telescope picks up a glow. Not scattered, not hazy, but concentrated deep at the core. A light no simple rock should emit. Within hours, brightness values surge to nearly 3 times above prediction. Yet there is no flicker, no chaotic plume, no comet tail at all. The object spins with clockwork precision, its light unwavering, almost mechanical. Then comes the shock. Independent observatories confirm a thermal pulse radiating like a heartbeat, repeating every few hours. Alongside it, Webb's instruments register bursts of radio signals, unlike any background interference. Patterns that refuse to match natural behavior, patterns that suggest intent. For scientists, this is not routine. Data archives are checked. Hubble images from months earlier reveal the same object already glowing while still beyond the orbit of Jupiter, long before solar heating could awaken comet activity. That glow is steady, measured, and stronger than anything in the models. At 6 astronomical units from the Sun, in a region where ice should rest in frozen stillness, 3I Atlas breaks every rule. Instead of lying quiet, it burns with an eerie glow, wrapped in a sheath of light that clings to its body. From there, the mystery only deepened. On August 18, 2025, the James Webb sent back fresh data. At Johns Hopkins, Dr. Carrie Liss and her team began to unravel the spectrum of the 3I Atlas, peeling it apart in search of answers hidden within its strange light. The basics were there: water ice, carbon dioxide, the standard chemistry of comets. But layered on top of those familiar markers were lines that simply didn't fit. Several absorption bands had no match in existing catalogs. The reflectivity profile hinted at metallic alloys. some resembling rare Earth elements only ever produced through advanced manufacturing on Earth. Then came the true anomaly. Buried deep in the spectrum were features that mirrored the signatures of exotic quantum materials. These were the kind of structures theorists described in dense physics journals, but no telescope had ever observed them in nature. For Liss's group, the implication was hard to ignore. Random cosmic chemistry no longer explained what they were seeing. On paper, this looked engineered. By late August, access to Webb's raw feeds began to narrow. NASA and the European Space Agency issued new data protocols under the banner of planetary security. Within the Secure Exploration Initiative, a working group convened under an unnamed coordinator. Behind closed doors, they debated a step that had been avoided for decades: sending a message. After days of argument, the vote was taken. A simple transmission was prepared. Prime numbers, the periodic table, fundamental constants, nothing more. The signal was sent toward Atlas. 72 hours later, a reply came back. A narrowband pulse, faint and distorted, but timed to the second. The return signal aligned precisely with the original transmission window. What had been speculation now became something more. The data was immediately locked down. Communications were rerouted to classified channels. Inside the agencies, the mood shifted from curiosity to something closer to unease. Outside, speculation spiraled. In parallel, the International Astronomical Union hosted its August debate. 4 natural models were tested: outgassing jets, radiogenic heating, dust scattering, and mass estimate errors. Every possible explanation was tested and dismissed. None could unravel the puzzle. The sudden surge in brightness, tripled beyond expectation, remained unexplained. The steady pulse of heat, almost mechanical, defied natural models. The repeating radio signal offered no easy answer, and the sharp 40% flare, paired with a shift in its trajectory, sealed the mystery even tighter. As the weeks advanced, the evidence only grew heavier. Independent checks from Hubble, TESS, and the European Space Agency all confirmed the same findings: rare alloys, uncatalogued absorption lines, signals too precise for background noise, a course change too deliberate to ignore. And now, with September's close approach only days away, anticipation has reached its peak. Every major observatory is preparing for direct study. The outcome is uncertain, but one fact is undeniable. 3I Atlas has broken every rule in the book of planetary science. Its arrival will either expand our understanding of interstellar objects or force humanity to face something far. The cosmos as a mirror. From the crude wooden tubes of Renaissance astronomers to the razor-sharp eye of the James Webb Space Telescope, humanity has always searched the skies for meaning. Webb was more than a machine. It was a window through time itself, designed not just to capture images, but to decode the very structure of the universe and trace its evolution from the first sparks of creation. Every fragment of data, every faint flicker of light, pulled us closer to understanding where we belong in this infinite story. And then, the anomaly appeared, a signal. It wasn't random noise or background static. It carried a pattern, something that felt intentional. Its origin was unknown, but its meaning was undeniable. In that instant, the universe no longer seemed silent. It felt as though it had finally spoken back. Scientists raced to test the signal. Did it bend to gravity? Was it tangled with electromagnetic interference? Did redshift or blueshift change its nature? To their surprise, the signal behaved exactly as the laws of physics predicted. Yet its strange order, its uncanny rhythm, whispered of something more. Philosophers entered the debate. What does it mean to confront the truly unexpected? Could a single piece of evidence rewrite centuries of human knowledge? For some, it was a chance for awe. For others, it threatened to dismantle the belief that humanity stands at the center of everything. Culture wasted no time. The enigma spilled into myths, stories, and conversations. Was it contact? Was it a warning? Or was it the universe reminding us we are not the only voice in the dark? After the silence, sometimes the loudest discoveries aren't explosions of sound, but the silence that stops the world cold. History has seen events that fade without leaving much of a mark. And then there are moments that ripple through generations, shifting science, culture, and imagination. The sudden shutdown of the James Webb Space Telescope falls into the latter. People will remember it not only for the breathtaking discoveries it made, but for the night it went quiet. It wasn't routine maintenance, and it wasn't a malfunction. It was a pause born of something far more unsettling, a silence that reached beyond hardware and software into the heart of our relationship with the universe. Behind the silence, experts sift through the data, line by line, running endless simulations. Every test edges us closer to clarity while reminding us that in science, certainty is never given, only earned. This enforced pause became more than a technical decision. It became a mirror, reflecting our ambition, our humility, and our readiness to face mysteries bigger than ourselves. Even if the anomaly never reveals a clear answer, the fact that humanity stopped to listen has already changed how we see the cosmos. Generations may look back at this not as a malfunction, but as a threshold. A doorway cracked open, hinting at something far greater waiting beyond. The awe and caution that led NASA to still Webb is the same awe anyone feels when staring at the night sky, wondering what lies in the dark. Global reactions. When the anomaly was confirmed, it didn't stay hidden in technical reports or private channels. The discovery spilled out into the world, and every group that touched it reacted in their own way. Inside observatories, astronomers were the first to confront the signal. Some leaned into their skepticism, combing through raw numbers, hunting for errors, or insisting it was an artifact of instrumentation. Others admitted, quietly at first, that the data carried a rhythm too exact to dismiss. In hushed meetings and late-night video calls, they wrestled with a possibility most had trained their entire careers to treat with caution. The media wasted no time. Headlines raced across major outlets, each spinning the mystery in ways that captured attention, but often blurred facts. The words heartbeat, unnatural, and transmission flashed across screens, igniting conversations far beyond the scientific community. Television anchors spoke with equal measures of awe and anxiety, while editors debated how much fear to stir and how much wonder to emphasize. Then came the public. Social media feeds erupted. Some joked about alien neighbors, turning the signal into memes and viral soundtracks. Others spoke of destiny, of humanity finally standing at the edge of cosmic contact. And woven through all the noise was a current of unease. Questions about what such a discovery could mean for religion, politics, or even survival. Governments took notice too. Intelligence analysts scanned the data alongside scientists, assessing whether the anomaly posed a threat or an opportunity. Closed-door meetings framed it not only as a scientific event, but as a matter of security and strategy. In homes across the planet, families gathered around screens, trading theories and fears. Teachers brought it into classrooms, turning lessons into debates about science fiction versus science fact. Religious leaders weighed in, some calling it a sign of creation's vastness, others urging caution about chasing mysteries not meant to be solved. For one fleeting moment, the entire world was synchronized, not in agreement, but in attention. Science and imagination collided on a global stage. The cosmos was no longer a silent backdrop. It had sent a pulse across the void, and every corner of humanity was left asking the same question: what happens next? Thanks for watching. See you in the next one.